is approximating area by adding up a bunch of rectangles. And so that means that RRAM, LRAM, and MRAM are all Riemann sums. So yesterday we approximated area by adding up a bunch of rectangles. But I didn't want to throw a ton of vocabulary words at you. So I didn't use the term Riemann sum yesterday. But we were doing Riemann sums yesterday. We were just adding up a bunch of rectangles, and we were using those rectangles to approximate the area. Okay? So that's all a Riemann sum is. Approximating area by adding up a bunch of rectangles.
That's an E.
In the Riemann, yeah, it's R-I-E-M-A-N-N. It's a guy's name who did this first. Yeah, sorry, that's R-I-E-M-A-N-N. Okay, so we're going to do some more of that today. And we're going to look at f of x equals 2 plus 5x. And we're going to estimate the area under the curve from x equals 3 to x equals 7. And for part A, we're going to use 4 rectangles. And they're going to be right-hand rectangles. Okay, so we're going from 3 to 7, right? So that means we've got a total space of 4 that we're trying to cover. And we want to divvy that up into 4 rectangles that are equal width. So we're going to divide that space up into 4 equal parts. So what this figures out for us is that the width of each rectangle is going to be 1. So we're going to have, here's our curve. We're going from 3 to 7. We're going to have a rectangle from 3 to 4, and then a rectangle from 4 to 5, and a rectangle from 5 to 6, and then finally a rectangle from 6 to 7. So here's the bottom of our first rectangle. There's the bottom of the second one, bottom of the third one, bottom of the fourth one. Okay, so I'm going to start with this one here, the one that goes from 4 to 5. We're asked to do right-hand rectangles. So how can I find the height of this rectangle? Yeah, put the 5 into this, right? The height of the function is the y value of the function. So the height of this rectangle is 22, because 5 times 4 is 20 plus 2 is 22. So the height of that rectangle is 22. And what's the width of it? 1. So you take 1 times 22 to get the area of it. Okay, then for the first one, the height's going to be, it's not 22. It's 27. Guys, can't even take 5 times 5 plus 2. Come on. Is everybody good with the 27? The first one is 22, right? The height of this rectangle is 22. So now I've got this rectangle and that one. And then I'm going to add up a third one. So the height of that one will be 32. And then the height of the last one will be 37. So I'm just taking the width of a rectangle times the height of a rectangle, and I'm doing that 4 times to get the area of 4 rectangles. And I'm adding that all up, so it comes out to 118. Okay, so now for part B, I'm going to use 8 rectangles instead. Okay, so when I do 8 rectangles, I'm still going from 3 to 7. So I'm still trying to cover a width of 4. But now I'm going to divide it up into 8 equal parts. So now the width of each rectangle is 1/2. So there's going to be a rectangle from 3 to 3.5. And then another rectangle from 3.5 to 4. And another one from 4 to 4.5, et cetera, et cetera, et cetera, right? So I'm going to spare you the details on that. It comes out to 113. Okay, now why would we want to do 8 rectangles instead of 4 rectangles? Because it's more accurate, right? If I divvy this up into 2 more rectangles, it's more accurate because there's less overlap. Now I just have this overlap and that overlap, whereas before I had that entire overlap, right? So this 113 is a better approximation than this 118. So how could I get an even better approximation? Do 16 rectangles, right? Because then the overlap would be even tinier than with 8. Yeah. Yeah, I just decided, yeah, for simplicity's sake, they're all from the right. It doesn't really matter, because eventually they're going to get so thin that the right side and the left side are pretty much matching up with each other. But yeah, for ease, for consistency, we'll just go right hand every time. Okay, so if you're okay with me not doing this, I'm just going to tell you the answer. I mean, I can write it all down if you want. Yeah, okay, all right, I thought so. I thought you'd just believe me. Okay, so it's 110.5 if you do 16 rectangles. Okay, so now for part D, we're going to make a guess for the exact area. So I'm going to make a table. And in the first column, I'm going to have n. And n represents the number of rectangles. So in part A, I did 4 rectangles, right? So n is 4. and I figured out the area. And the area was 118 when I did 4 rectangles. But then for part B, we quote-unquote did 8 rectangles, and it came out to 113. And then we did 16 rectangles, and it came out to 110.5. Okay, so we're supposed to make a guess as to what the area is. So this answer was better than that one, right? And this answer was better than that one. So if I try to see what these answers are getting close to, then we can guess what the exact area is. So what do you think? We're just guessing. You don't have to be right. Yeah. Okay, cool. So we're going to guess 110. And that's a reasonable guess because these numbers could, she's saying, hey, it went to decimals here, so I'm thinking maybe that's going to stay the way it is. Maybe the next one's going to be 110.2, then 110.1, et cetera, et cetera. Maybe it is getting close to 110. That's a reasonable guess. Okay, so what we're doing here is we're finding the area, the approximate area, right? And we're taking the number of rectangles and making it bigger and bigger. And then we're looking to see what our answers are getting closer and closer to. And this is how you find exact area. Okay, so now we're going to actually find the exact area. What is this, part D? All right. And this is going to take a while. If I walk too fast, it doesn't follow me. I get too excited sometimes. You know, you've seen that. Okay. Okay, so what we need to do is we need to come up with a formula for finding the area from 3 down to 7 using any number of rectangles. Okay, so n represents the number of rectangles, right? So if I want to find the width of each rectangle, I need to take 7 minus 3 and divide it up into n equal parts. For example, if n was 16, then this would be 4 divided by 16, and then the width of each would be a fourth, right? Or if this was 8, then it would be a half. Okay, so this is just a formula for finding the width of each rectangle. So 4 over n represents the width of each rectangle. So I have a rectangle here that has a width of 4 over n. And then I have another one that has a width of 4 over n. And then another one that has a width of 4 over n. 4 over n, et cetera, right? Okay, so what is the x location right there? Okay, let's take a step back. Let's say the width was a half. What would that x location be? 3 plus a half, right? AKA 3 and a half. If the width was a fourth, then this x location would be 3 and a fourth. So if the width is 4 over n, then this x location is 3 plus 4 over n. If that x value is 3 plus 4 over n, how do I find the height of rectangle number 1? Plug that in to the formula, right? If that was 3.5, we would take 2 plus 5 times 3.5. If that was 4, we'd take 2 plus 5 times 4. So since that's 3 plus 4 over n, we're going to take 2 plus 5 times 3 plus 4 over n. So what does this represent? The height of which one? The very first rectangle, right? This represents the height of the first rectangle. What's the width of the first rectangle? 4 over n. So if I multiply this by 4 over n, then I have the width times the height. So this whole mess here is the area of rectangle number 1. Okay, now I need to move on to rectangle number 2. So I've already got the area of this first rectangle. Now I'm going to move on to this rectangle. So I need the x location there. So again, stepping back, let's pretend the width was a half. I would have to take 3 plus 2 halves to get there. So that would get me to 4, right? So this time I need to take 3 plus 2 of these to get there. So the x location there is 3 plus 2 times 4 over n. The 3 plus 2 of the widths will equal that. Is everybody doing okay? Are you sure? Okay, so that's my x location, right? So how do I find the height of rectangle number 2? Plug that into my formula, right? So that'll be 2 plus 5 times 3 plus 2 times 4 over n. So this mess is the height of rectangle number 2. What's the width of rectangle number 2? 4 over n, because the width is consistent, right? Every time the width is 4 over n. So if I take that height times that width, then I get the area here of rectangle number 2. Okay, now moving on to rectangle number 3. So now I have this area. I'm going to go for this area. I need this x location, right? Well, to get to that x location, I just add 3 4 over n's. Yes?
What I'm not understanding is, like, wouldn't it be endless? Because 4 over n is the width of, if it's like really, really small, couldn't it just be an endless process?
No, because eventually we're going to get to the last rectangle, which is rectangle number n, because we're doing n rectangles, right? And then we're going to have to add n of these, and it's going to be 3 plus 4, which is 7. So we're going to stop when we get to 7. No, you're asking a good question. So what I'm saying is, are you clear that on the third rectangle that should be a 3?
Yeah.
And on the fifth rectangle that should be a 5?
But what I'm wondering is, wouldn't that just keep going on? Like,
So right now we're finding the area using n rectangles. instead of using 4 or 8 or 16, we're using n of them. So we're going to stop at the nth one. Just like if we were doing 4, we'd stop at the 4th one. So when we stop at the nth one, that'll be an n.
So if it's 4 over n, so the n is...
The n's cancel, and then we'll be stopping at 7, which is where we're supposed to stop. Great question. Is everybody else okay with this 3 times 4 over n? Yeah.
But what number is before
N minus 1. Yeah, let's deal with that later, okay? If n happens to be 8, then the one before it is 7. And then we're going to end up doing 8 of them. We'll do the 7th one, which is n minus 1, and then the 8th one, which is the last one. Yeah, it is a little abstract, though. Okay, so in general, the height is going to look like this. So for the first rectangle, that was a 1. For the second rectangle, that was a 2. For the third rectangle, it'll be a 3. For the fourth one, fifth one, etc. Okay, so in your notes somewhere, you need that I represents the number of the rectangle you are currently working on. So n represents the total number of rectangles. So if you're doing 8 rectangles, then n is 8. But I represents what one you're on right then. So when I is 1, you're doing the first rectangle. When I is 2, you're doing the second rectangle. When I is 3, you're doing the third rectangle, et cetera, et cetera, et cetera. Okay, so when we were working on the second rectangle, that needed to be a 2, and so that's why I is 2. Okay, so we could keep doing this, right? We could write plus and plus, dot, 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 right? And then we'd write the same thing with a 3, same thing with a 4, same thing with a 5, et cetera. And we'd add all those up. But there's a shorter way to write down adding up a bunch of things. So you haven't seen this in a while. But this symbol means add up a bunch of things. I need to write my width down, right? Because this is the height. So I need to multiply by the width. And I want I to be 1 to start out with, right? Because I'm going to start on the first rectangle. And then later I want I to be 2. And then I want I to be 3, et cetera, et cetera, et cetera. And I want to stop at my nth rectangle. So if I was doing 8 rectangles, I would stop at 8. But if I'm doing 16 rectangles, then I would stop at 16. So since I'm doing n rectangles, I'm going to stop at n. And then, like Dan pointed out, then that's going to be nice because then this will end up being 7. Which is where I'm supposed to stop, right? Because I'm finding the area from 3 to 7. It says somewhere on the board, right? Okay, now this mess is the approximate area. For example, if n was 4, it would look like this. 4 things added together. If n was 8, this mess would end up being 8 things added together. So this is the approximate area. So in order to find the exact area, I've got to take the n and make it get bigger and bigger. And then take the limit of that. Okay, so this looks nasty, but it's not quite as bad as it looks. It will be a little bit painful, but we've got plenty of time. we're going to calculate this limit. Okay, so the first thing I'm going to do is I'm going to distribute this 5. So that'll give me 15 plus 20I over n. Is everybody okay with the 20I over n? And would it be okay if I just went ahead and added the 2 in at this time and made that 17? Okay. So there's my parentheses, 17 plus 20 over n times 4 over n. I'm going to add that up from 1 to n, and then eventually I'm going to take the limit as n goes to infinity of that. Okay, next thing I want to do is distribute this 4 over n. So that'll give me 68 over n plus 80I over n squared. Okay, next thing I'm going to do is, well, I'm going to write this out the long way, because this mess is kind of hard to understand. So when I is 1, this is 68 over n plus 80 times 1 over n squared. And then when I is 2, it's 68 over n plus 80 times 2 over n squared. So this whole summation thing is just shorthand for this. I don't want to write out all these things added up. So I've just condensed it down to that. But sometimes you have to go back to this to remember what's going on. Okay, so the first thing I'm going to point out is I could regroup this, right? Couldn't I add the 68 over n's all together? And then later add these? Because that's the way adding works, right? I can regroup that way. So I'm saying just pick off these 68 over n's, group those all together, then pick off all these second terms and group all those together. Okay, so that means I can turn this into adding up the 68 over n's first, and then later adding up the 80I over n squareds. Okay, now this is just a bunch of the same thing added together, right? So if I was doing 3 of them, I could just multiply that times 3. or if I was doing 8 of them, I could just multiply that times 8. So since I'm doing n of them, I can just multiply that by n. Yeah, which is going to come out to 68. That's true. But for now, I'm making sure everybody's okay with this. Okay, then for this, I have this plus this plus this plus this, right? So I could factor out the 80 over n squared, and then I'd have 1 plus 2 plus 3, et cetera, et cetera, et cetera. So that's 80 over n squared times the sum, I equal 1 to n of I. Because this is just I equal 1 plus I equal 2 plus I equal 3, et cetera, et cetera, et cetera. Yes?
Where did the n come that you're multiplying to 68 over n?
So you see that this is just a bunch of 68 over n's added together? That's what this is. So if this was a 3, then I would have 3 of them added together. So I could just multiply it by 3. Good. Everybody doing okay? Okay, now there's a formula for this. And for right now, I'm going to ask you to believe me, but I probably will have time at the end of class to convince you that the formula I'm about to write down is true. But for now, just believe me that this equals n times n plus 1 all over 2. And this is 68, just like Bryn said, so might as well write that down. Okay. Okay, now conveniently, this n will cancel with one of those n's. So we've got 68 plus 80 over n times n plus 1 over 2. We're taking the limit as n goes to infinity of that. Okay, now I'm going to distribute the 80. So that's 80n plus 80 over 2n. Then limit distributes past plus, right? So what's the limit of 68? 68, because the limit of a constant is the constant. So then I'm going to do this second limit. What's going on with this limit? It's infinity over infinity, right? We're not taking a derivative, we're just taking a limit. But yeah, you're thinking good. It's definitely two things divided. And if this number was really big, the top would be really big, right? So it's going to infinity. And the bottom's going to infinity as well. So this is infinity over infinity. Is everybody okay with that? And how do we deal with infinity over infinity? L'Hopital's rule, right? So we just take the derivative of the top, which is 80, and the derivative of the bottom, which is 2, and take the limit of that. And then 80 divided by 2 is 40. Limit of 40 is 40. So the final answer for the exact area is 108. So we had a guess of 110. That wasn't a bad guess. That's why table limits aren't so good. So we computed the limit more analytically, a lot more analytically, right? And we got 108. So that's the exact answer for the area. Okay, so now I need to make sure you have this formula written down that we used. Sum I equals 1 to n of I is n times n plus 1 over 2. I still will probably have time to show you where that comes from, but I'm going to leave it till the very end. You also might need this formula. So maybe on a different problem like this, you'll boil it down to this instead of just I. So then you'll put that in instead of this. And then there's this one that is the sum of the first n cubes. I've always found it interesting that this is this formula squared, even though it's the cubes. You do not need to have these memorized. Do not memorize these. AP test doesn't expect you to. I don't expect you to. If you need it on the test, it'll be on the test, listed on the test. Okay, but you do need to know how to use them. Okay, so now I'm going to find the exact area an easier way, and you're going to be upset with me. So what am I on? Part E? F? All right, so I'm going to find the exact area using geometry. So I drew this thing as a curve, right? But 2 plus 5x is a straight line. So if I'm trying to find the area from 3 to 7 underneath a straight line, I can just do a rectangle and a triangle. So I'm going to plug 3 into the function to figure out how tall this is. It's 17, right? 5 times 3 plus 2. Then I'm going to plug 7 into the function. It's 37. 5 times 7 plus 2. So the rectangle that I'm looking at the bottom has width 4 and height 17. And then the triangle has base 4 and height 20. See where I'm getting the 20? So then this is 68. Recognize that's 68. And this is 40. So it's 108. Okay, but this will only work. This specialized method will only work if it's a straight line or it makes a circle shape or something like that. But this nasty method will work no matter how crazy the curve is. Okay, so that's why I showed you that first. Plus, this kind of solidifies in your mind that, okay, yeah, that whole mess was kind of unbelievable that it worked out. It's right. It's 108. That's the right answer. Okay. Everybody okay? All right, so I still have a couple minutes, so let me show you. Let me convince you that that top formula over there, n times n plus 1 over 2, is true.
You want to write it down?
I can't believe that you wouldn't want to write down everything that I said, word for word. Okay, so we've got the sum I equal 1 to 6 of I. Let's say we were going to add up the sum I equal 1 to 6 of I. Okay, so that would mean first make I 1, then make I 2, then make I 3, then 4, then 5, then 6. That's what I equal 1 to 6 means. And then add them all up. So the easiest way to add these up is to pair them up. So notice that there's 3 pairs of 7. Three pairs of 7. So now I'm going to change it to 8, right? So now there's pairs of 9. How many pairs of 9? 4 of them. Keep messing that up, sorry. 4 pairs of 9, right? So in general, if that's n, then there's n divided by 2 pairs of n plus 1. And the n plus 1 is the last number plus the first number is how you figure out what the pairs add up to. Everybody good? Are you sure? Okay. So I have to, for some reason I have page 302 on Classroom, and I'm not sure why, so I have to adjust I have to give you the right homework.